So friends, today's topic is the limitation of Mendeleev's periodic table. As you know, Mendeleev's periodic table was a great task, great job done by Mendeleev in 1869. But still, after preparing his periodic table, there were some limitations we found, and these limitations we are going to discuss today. The first limitation is the position of hydrogen in periodic table. Actually, this limitation is still today limitation. It has not been resolved today. So the limitation of Mendeleev's periodic table, the first point is to discuss the place or the position of hydrogen in periodic table. So let's find out where to be placed hydrogen in periodic table. We have two options, friends. Either hydrogen is to be placed in group 1, and the second option is hydrogen is to be placed in group 17. So we have some important points to discuss. The first point is the electronic configuration. Friends, the electronic configuration of hydrogen is, as you know, it has just one electron in its K cell. Similarly, if we go for the group 1, in group 1 elements, the first element is lithium. In K cell 2 and L cell, one electron is there. In sodium, friends, it is 281 Kl M cell. So these two elements has one electron each in outermost cell. Similarly, also in potassium, rubidium, cesium, other elements of group 1 consist just one electron in outermost cell. So if we discuss about the electronic configuration point, hydrogen is to be placed in group 1. So considering the electronic configuration, hydrogen is to be placed in group 1. If we talk about the second thing, if we compare hydrogen with, friends, group 1 element, sodium is a group 1 element. You can see sodium chloride, similar compound we got hydrogen chloride. One sodium combining with one chlorine, similarly one hydrogen combining with one chlorine. So here with oxygen, sodium is combining with oxygen, two sodium atoms, here two hydrogen in water molecule, and friends, sulfur with sulfur, it is also equal. So we can conclude with this table that hydrogen is just like group 1 element because its chemical reactions are also similar to group 1 elements. So 2 points, chemical properties as well as, friends, electronic configuration is in favor of group 1's position of hydrogen. But friends, on the other hand, if we consider the other things just like the physical properties, hydrogen is in gaseous form at room temperature, whereas group 1 elements are in solid form. So this is one controversy. We are not able to put it in group 1. The second important thing, friends, hydrogen is diatomic. Always the two atoms of hydrogen are together. Whereas, friends, lithium, sodium, potassium, these group 1 elements are, friends, monoatomic. So this is also a big controversy, and that is the reason we are not able to put hydrogen in group 1. Two positive things are there, but besides that, two negative things are there, and that's why hydrogen is not to be placed in group 1. Next, friend, is so where hydrogen is to be placed. So the next point is, friends, about the group 17. Group 17 is halogen group, friends, and halogen group consists the 4 important elements: fluorine, chlorine, bromine, and iodine. These elements, if we discuss, they all are diatomic. They are, friends, diatomic, and similarly hydrogen is also diatomic. So this is similarity. One more similarity is here. This is gaseous elements. Hydrogen, fluorine, chlorine are gaseous elements. So this is second similarity. And also, friends, we can consider that hydrogen, if gain one electron, it will become helium like. Similarly, chlorine, friends, gain 1 electron, it will become argon like. Fluorine gain 1 electron, it will become like neon like. So this is also we can consider as a similarity. All elements gain 1 electron and become inert like electronic configuration. So this allows us to put hydrogen in group number 17. But the last thing is, friends, the electronic configuration of hydrogen and chlorine or halogen group. In all halogen group, this is 287. In fluorine, friends, it's just 2 and 7. There are 7 electrons in outermost shell of the fluorine and chlorine or all halogen elements, whereas, friends, in hydrogen it is just 1. This is the big controversy of electronic configuration, does not allow us to put hydrogen in group number 17. Why, friends? Because the whole periodic table is prepared on the base of electronic configuration and atomic masses. So electronic configuration is a major term we have to put in mind, but it is not favoring us, so we are not able to put hydrogen in, friends, group 17 still, and that's why the place of hydrogen is uncertain even today. It is also a very important, we can say, limitation of modern periodic table too. Okay, second important thing, friends, is limitation is about the isotopes. What are isotopes? The elements having similar atomic number but different atomic masses are to be said the isotopes. These isotopes are not placed in periodic table. Why? Because their atomic numbers are same. If we consider hydrogen, so hydrogen, deuterium and tritium, 3 elements, these 3 are isotopes, and this, out of these 3, only hydrogen has given the place in periodic table, deuterium and tritium are not. So Mendeleev was not able to put all the isotopes in periodic table. Still today, friends, any isotope, either it is of chlorine or hydrogen or oxygen, any other elements, isotope has not been placed in the periodic table. Clear? So these two are the two limitations of the periodic table.